Hello everyone. In this session, I am going to discuss about the one of the numerical on transient heat transfer. The numerical is that a 15 diameter mild steel sphere K equal to 42 watt per meter degree Celsius is exposed to cooling air flow at 20 degrees Celsius, resulting in convective coefficient H equal to 120 watt per meter square degree Celsius. Determine the following. First one, time required to cool the sphere from 550 degrees Celsius to 90 degrees Celsius. Second one, instantaneous heat transfer rate 2 minutes after the start of cooling. For the mild steam, the properties are given: rho equal to 7850 kg per meter cube, Cp 475 joule per kg degree Celsius, alpha equal to 0.0045 meter square per hour. This is a sphere having the transient heat transfer that we have to determine the rate of, that is the time required for the cooling the sphere from 550 degrees Celsius initial temperature to the final temperature 90 degrees Celsius, and also we need to determine the instantaneous heat transfer rate 2 minutes after the start of cooling. Moving to this one, what are the given data are there? We'll take first d equal to 15 mm 0.015 meter, that is the diameter of sphere. That is, if you take the radius of the sphere, r equal to 0.0075 meter. The K equal to 42 watt per meter degree Celsius, thermal conductivity of the sphere material. T equal to 20 degree Celsius, surrounding temperature, that is air temperature. H equal to 120 watt per meter square degree Celsius, convective heat transfer coefficient. Ti initial temperature 550 degree Celsius. T of T 90 degrees Celsius, that is the final temperature. Rho density 7850 kg per meter cube. Cp 475 joule per kg degree Celsius. Specific heat of sphere alpha equal to 1045 meter square per hour, and that is equal to 1.25 into 10 raised to minus 5 meter square per second. This per hour whatever is there, it is converted into per second by dividing with the 3600. Whenever alpha is given meter square per hour or meter square minute, we have to convert it into a meter square per second. Thermal conductivity of sphere, that is we are thermal diffusivity of sphere is the, and what is asked to find in this one. First one, time required to cool the sphere from 550 degrees Celsius to 90 degrees Celsius, T. Second, instantaneous heat transfer rate 2 minutes after the start of cooling, QI. Moving to the solution, the first one, we have to find the characteristic length of the sphere, and that is characteristic length is given by volume to the area ratio V by A. The volume of the sphere is 4 by 3 pi r cube and area of the sphere is 4 pi r square. Then this becomes r by 3, and r is, we have the radius 0.0075 by 3, it will become 0.0025 characteristic length. Then now Biot number is given by Vi is equal to HLC by K. H is 120, LC is 0.0025, K is 42. Then that becomes a 0.00713, which is less than 0.1. Hence, lumped system analysis is applicable. As we know, if the Biot number is less than 0.1, we have to use the lumped system analysis within the error of 5%, less than 5% error. That for that we can use. If it is more than 0.1, then we cannot use the lumped system analysis. The error will be more. Then we have to go for using the transient temperature charts. Now we are using the lumped system analysis. The temperature distribution equation is given by the lumped system analysis. That is T of T minus Ta by Ti minus Ta equal to e raised to minus Bi minus into F naught. That is a Biot number into Fourier number. T of T, that is given again, it will be given by the other equation, that is T of T minus of Ta by Ti minus Ta equal to e raised to minus Hat by rho Cpv. where T of T is the temperature after the particular time, Ti is the outside temperature, Ti is the initial temperature, and again this Ti is the air temperature or a outside temperature. And here H is the heat transfer coefficient, A is the area of the sphere, T is the time for that to attain the temperature, rho is the density, Cp is the specific heat, P is the volume. Then this we can rearrange in such a way that T of T minus Ta by Ti minus Ta equal to e raised to minus Ht by rho Cp Lc. Here V by A ratio we can take. Then if we take the V by A ratio, that will become a characteristic length Lc. Then that Lc is taken in the denominator here, V by A ratio. Therefore, it will become this equation. By substituting all the terms except T, we can have, that is here exponential term can be sent to that side. That will become a ln term, ln of T of T minus Ta by Ti minus Ta equal to minus Ht by rho Cp Lc. By substituting all the values, ln of 90 minus 20 by 550 minus 20, 1 is equal to minus of 120 into T by 7850 into 475 into 0.0025. After the calculation, we are going to have this time T equal to 157.26 seconds. This is the first one, the time what is asked for the cooling the PF from 550 degrees Celsius to 90 degrees Celsius. Further, the instantaneous heat transfer rate 2 minutes after the start of cooling. That here the time is given 2 minutes, therefore it will become say 120 seconds. Then instantaneous heat transfer rate is given by Qi equal to minus Ha Ti minus Ta multiplied with the e raised to minus Bi into F naught. That is a Biot number into Fourier number. That again the Biot number and Fourier number can be written like that. This the first term will be remain same, minus Ha Ti minus Ta e raised to minus Hat by rho Cp V. This again we can change this one, the rearrange, minus Ha Ti minus Ta into e raised to Ht by rho Cp Lc, because here V by A is taken, A is sent to the denominator, where V by A will be the Lc. By substituting that, this equation we are going to get. Then by substituting all the values, the Qi equal to H is 120, that is minus 120, area is 4 pi r square, 4 pi into 0.0075 square, and Ti is initial temperature 550 and outside or air temperature is 20 degrees. Okay, then e raised to, okay, that is H is 120 and T is also 120 second, rho is 7850 and Cp is 475, Lc is 0.0025. After the calculation, we are going to get the Qi as the minus 9.592 watt. Here these values, the whatever the time required for the cooling 550 to 90 degrees Celsius, what we got as 157 point something, and this Qi minus 9.592 watt. This by taking this term Hat by rho Cp. If you separately calculate this Biot number as a HR by K and Fourier number, okay, that is a Fourier number alpha T by Lc square, and Biot number is HLC by K, then substituting those values, if you calculate the Qi and also that time, okay, little variation we are going to get. Okay, don't bother about that one. In that way also we can calculate here this way by taking this term as a m. Also we can calculate the rate of heat transfer as well as the time taken in the lumped system analysis. Okay, that little variation is considerable, and also the both the values alpha and all other terms if given, then we have to use the any one method to calculate that time as well as the instantaneous heat transfer or a total heat transfer. Further, the numericals I am going to solve in this transient heat transfer in the next sessions. Thanks for watching. If you like, share, subscribe my channel and comment.